let's see this case. Masses m1, m2 and m3 are connected by strings of negligible mass which pass over massless and frictionless pulleys P1 and P2 as shown in figure. So these three blocks M1, M2 and M3 are connected over pulleys in such sort of an arrangement over here. Now what has happened over here is the masses move such that the portion of the string between P1 and P2 is parallel to the inclined plane, and the portion of the string between P2 and P3, this is not M3, this is P3, is horizontal. Okay, this was P2 only, this was P2 and M3. That means this part is parallel to the incline and this part over here is horizontal. This over here is parallel to the incline and this part over here is horizontal. Masses M2 and M3 are of 4 kg each. So value of M2 and M3 is given to you as 4 kg. And the coefficient of kinetic friction at all surfaces 0.25. So mu for all surfaces is 0.25. If the inclined plane makes an angle of 37 degrees with horizontal, this angle is given as 37 degrees. If mass m1 moves downward with a constant velocity, then find m1 tension in the string. See, this goes down with velocity which is constant. If this goes down with velocity which is constant, this would move up with constant velocity. And this would move forward with a constant velocity. See, velocity for everyone, if it is constant, then acceleration for everyone would be 0. So that means net force on everyone must be equal to 0. Let's say the string is tied with a tension T1 and the string is tied with a tension T2. So if you pick this first block of mass m1, on this m1g would act downward, tension T1 would act upward, and since its acceleration is 0, so m1g must be equal to T1. Pick this third block m3. If you see this third block, on this third block m3, m3g would act downward, normal reaction n3 would act upward, tension on it would be T2 forward, and on it friction would be Fk backward, where acceleration of this part is also 0. So T2 must be Fk, which is mu into m3 into g. And if you pick this block m1, m2, let's see it over here. This m2 block is on an inclined plane of angle theta. So it would have its m2g down the cos theta down the incline, m2g sin theta parallel to the incline, normal reaction n2 acting upward, tension T1 tries to pull it up, T2 tries to pull it down, and also there is a friction Fk2 which tries to pull it down, and since it moves with a constant velocity, so T1 for this guy must be m2g sin theta plus T2 plus Fk2 can be written as mu into n2. T1 over here would come out equal to m2g sin theta plus mu m2g cos theta plus T2 over here would be mu m3g, and T1 over here can be written as m1g. So m2g sin theta plus mu m2g cos theta plus mu m3g must be m1g. G part over here gets cancelled. So over here m1 must be equal to m2 plus mu m2 sin theta plus mu m2 cos theta plus mu times m3. m2 is 4, sin 30 theta is sin 37, which is 3 by 5, plus mu is 1 by 4, mu is given to us 1 by 4, into m2 is again 4, into cos theta would be 4 by 5, plus mu 1 by 4 into m3 is again 4. So 4 and 4 gets cancelled, 4 and 4 over here gets cancelled. So this is 12 by 5 plus 4 by 5 plus 1. So this is 16 by 5 plus 1, or 3.2 plus 1, which would come out to be 4.2 kg. So the value of first mass is 4.2 kg over here. Also, you need tension in the horizontal portion. Horizontal portion is this one. So you need T2. T2 would be equal to mu m3g. Mu is 1 by 4. M3 is 4. Gravity is 9.8. So this comes out to be 9.8 newtons. That's the answer.